Hi, I'm Anya Capy. Today, we will talk about safety and security for AI agents. As AI agents grow in capability, ensuring they operate safely and securely is paramount. It's crucial they align with your brand values to avoid posing risks to your reputation. Uncontrolled agents can execute misaligned actions, leak data, or generate inappropriate content. Key sources of risk include vague instructions, model hallucination, and prompt injections. This also includes indirect prompt injections from adversarial users or through tool use. To help, Google Cloud Vertex AI provides a multi-layered approach to mitigate these risks. This enables you to build powerful and trustworthy agents with strict operational boundaries. Let's review these mechanisms, starting with identity and authorization to control who the agent acts as. Next, you can use guardrails to screen both inputs and outputs for your model and tools. Then there's sandboxed code execution, which prevents security issues from model-generated code. We also have evaluation and tracing to assess the quality and correctness of an agent's output. Finally, network controls like VPC service controls confine agent activity to secure perimeters. Before implementing any safety measures, always perform a thorough risk assessment first. Now, let's explore the different risk categories you might encounter in more detail. First is misalignment, where agents pursue unintended goals, a behavior known as reward hacking. Another category is harmful content generation, which can include toxic, biased, or illegal content. This also creates brand safety risks, like using language that goes against your brand's values. The final category is unsafe actions, such as executing commands that can damage your systems. This includes making unauthorized purchases or leaking sensitive personal information and data. Now let's talk about some best practices for the security and safety of your AI agents. Let's begin with a deeper look into our first layer, identity and authorization. The identity a tool uses to perform actions on external systems is a crucial design choice. Different tools in the same agent can have different strategies, so careful planning is needed. First, let's discuss agent auth, where the tool interacts using the agent's own identity. This identity, like a service account, must be explicitly authorized in external systems. For example, by adding an agent's service account to a database's IAM policy for read access. Such policies constrain the agent to only perform actions the developer intended as possible. So if you grant read-only permissions, the tool will be prohibited from performing write actions. This approach is simple and best for agents where all users share the same level of access. If users have different access levels, this approach must be complemented with other techniques. Also, ensure lobs are created to maintain attribution of actions to the original users. Next up is user auth, where the tool uses the identity of the controlling human user. This is typically implemented using OAuth, where the agent acquires a token from the user. The tool then uses that token, and the external system authorizes the controlling user's action. User auth ensures agents only perform actions that the user could have performed themselves. This greatly reduces the risk of a malicious user abusing the agent to gain more access. However, delegated permissions like OAuth scopes can often be broader than what is actually required. Therefore, other techniques are often needed to further constrain the agent's actions. Now, Let's move on to using guardrails to screen your agent's inputs and outputs. A great place to start is with in-tool guardrails, by designing your tools defensively. You can create tools that only expose actions you want the model to take, and nothing more. This approach relies on the fact that tools receive two distinct types of input. There are arguments set by the model and tool context set deterministically by the developer. We can rely on that deterministically set information to validate that the model is behaving. For instance, a query tool can be designed to expect a policy to be read from the tool context. Gemini models also come with built-in safety features you can leverage. First are content safety filters, which can help block the output of any harmful content. They function independently from the models as part of a layered defense against various threats. Gemini models on Vertex AI use two different types of these content filters. Non-configurable filters automatically block prohibited content, like CSAM or personal data. Configurable filters let you set thresholds for hate speech, harassment, sexually explicit, and dangerous content. You can configure these filters based on probability and severity scores for your specific use case. Next, you can use system instructions for safety to provide direct guidance to the model. By providing specific instructions, you can proactively steer the model away from undesirable content. You can craft instructions to define content guidelines, sensitive topics, and required disclaimers. This also ensures the model's outputs align with your brand's unique voice, tone, and values. Let's talk about using callbacks and plugins to implement more of these security guardrails. Callbacks offer an agent-specific method for pre-validating tool and model inputs and outputs. Plugins, on the other hand, offer a reusable solution for implementing general security policies. When modifying tools isn't possible, the before-tool callback function can add pre-validation. The callback has access to the agent's state, the requested tool, and all its parameters. For reusable policies, however, plugins are the recommended approach for implementing security guardrails. Plugins are designed to be self-contained, letting you create plugins for specific policies. You can then apply them globally at the runner level, ensuring consistent security guardrails. Let's look at an example. The Gemini as a Judge plugin for evaluating inputs and outputs. It uses a model like Gemini Flash Lite to check for prompt injection and jailbreak attempts. If it decides an input is unsafe, it returns a predetermined, safe response to the user. Another example is the Model Armor plugin, which checks for potential content safety violations. Finally, the PII redaction plugin is designed to redact personally identifiable information. It does this before that information is ever processed by a tool or sent to an external service. Now let's discuss sandboxed code execution, which has its own unique security implications. Sandboxing must be used to prevent model-generated code from compromising the local environment. Google and the ADK provide several options for safe, sandboxed code execution. For instance, you can use the built-in code executor tool in ADK for data analysis. If you build your own code executor, we recommend creating execution environments that are hermetic. This means no network connections or API calls are permitted in order to avoid data exfiltration. Next, a quick note on evaluations. Always include testing your agent's safety guardrails. This will help you identify potential issues now and also when you make changes later. Another layer of defense involves using VPC service controls and other network controls. Executing your agent in a VPC ESC perimeter guarantees API calls stay within that perimeter. This greatly reduces the chance of any data exfiltration from your agent's environment. However, these only provide coarse controls, which is why tool use guardrails are so vital. And a final but critical point: always escape model-generated content within your UIs. If HTML or JavaScript isn't properly escaped, the text returned by the model could be executed. This could lead to data exfiltration, for example, through an indirect prompt injection attack. Proper escaping ensures that model-generated text is never interpreted as executable code by browsers. And that was our introduction to the topic of safety and security for AI agents. I hope it helped you better understand how to build your agents with security and safety in mind. I'm Anya Capy. Thank you very much for watching. Goodbye.